All right, so let's get into this quickly because there is a lot of stuff to go over in statistical reasoning. We've gone over so far the different types of studies, descriptive, correlational, and experimental in psychology, and the ethics of how you set those studies up. Let's talk now about once you have your findings, what does statistics look like and how you can use those in psychology, but also in the real world, also in everyday life. And that's something that I think that statistics are absolutely valuable for. So descriptive statistics are just like they sound, how you describe. It's statistics that are describing what they're finding. And they're used primarily in descriptive studies, but you can see these types of statistics in everything, experimental as well. So descriptive statistics, when we see these, it's primarily going to be seen through histograms, and that just shows how frequently a certain response was given. Right? Think about it. If you have choices between A, B, C, and D, this will show you that. If you're students on a quiz, the distribution between students who got had the amount of students they got an 85 on the quiz, number of students who got a 95 on the quiz, and 96, 97. And so these histograms will show you how many respondents put a specific answer or what their scores were. And then as we look on the X and Y axis here, we need to pay attention to that because they can be used to skew. And you notice that here on all three of these had the exact same value. 2 is blue and 10 for red. But the way that they drew their Y-axis really threw it off. So pay attention to the X and Y-axis and how it's drawn because it can drastically change what the histogram looks like. So next thing that you should be aware of, central tendency and the measures of those. There are 3 of those. Be aware of those 3. There are questions that I've seen in the past that have asked like measures of central tendency, and it had options on there that weren't central tendency. There's only these 3: mean, median, and mode. Right? If it asks you about range, that's not a measure of central tendency. We're only looking for these 3 things: mean, median, and mode. So mean is the most popular thing that you'll see. You'll almost always see that, and that is the average. Mode is the answer or response that pops up the most frequently. This one is very common or very popular when we're seeing like if we're having a smaller number of choices, but with lots and lots of choices, mode not quite as valuable. And then median is the midpoint, right? If we're thinking about the 50th percentile, what's right in the middle, not the average, but the median. Median not quite as thrown off by outliers. Okay, so let's talk about what that looks like and how that can be problematic. So a big issue here is going to be skew. In a good generalizable sample, typically the more people that you have, you're eventually going to find that people fall along one of these normal distribution curves, meaning mean, median, mode, or the central tendencies are all pretty much the same number, but oftentimes they can get skewed. And we'll talk a little bit more about that going forward. But how you fix a skew, the best way to do that is to get more respondents. The more respondents you have, the larger sample size, you're going to move away from those outliers and more towards a normal distribution. So we talked about those skews. You notice a total symmetrical distribution. A more normal distribution typically means a larger sample size, typically means it's more representative. This is kind of what we're going for. Most things will ultimately work its way back towards this. But oftentimes what we see are in sample sizes that are too small, or in things that or in studies that aren't quite as valuable or aren't quite as useful. We can get these skews, meaning that we may need more work to be able to get through it and be able to understand why it's skewed, and then ultimately move it back towards a more normal distribution. So what you see here on the positive and negative skew is the average being away from the median or the mode, right? In the symmetrical distribution, it's all towards the middle, but in a positive skew, the average is much higher than where the bulk of participants or respondents are. In a negative skew, the average is much lower than what their bulk of respondents are. Okay, so think about a test. If you've got a range between 50, 0, and 100, and the bulk of students scored lower than the average, it can be thrown off by, a couple really, really high outliers, right? Same thing by negative skew. If a couple students score extremely low, it'll mean that the average or the mean is really, really low, even though most students did pretty well. So negative and positive skews are where outliers, these things on the outside, throw off the average, which is what's mostly thrown off by the skew, or thrown off by outliers, and it causes a positive or negative skew. So I would definitely know that mean, or the average, is the most likely to be thrown off when you have significant outliers. All right, measures of variation. These are often what can be the most confusing for students. These ultimately tell us how wide-ranging our findings are. Okay, and so measures of variation, these are not central tendency. The range in a measure of variation tells us what the range of scores are. So again, if we're talking about test scores, a range of variation could be students scored between 70 and 100, so a range of 30. It's not perfect. It gives us a very crude estimate of variation. You don't know if 20 students took the test, 19 of them scored a 100, and one of them scored a 70. Right? Then the range would still be 70 to 100. But much more useful would be the standard deviation, telling us how much variation we get around the mean. So if we get this normal distribution curve to figure out the deviation, we have to figure out the range, we are going to figure out that ultimately, on a normal distribution curve, which is usually what to some extent what we're working with in psychology, especially on tests and on intelligence tests, surveys, things like that, we are going to see that 68% of respondents or test takers are going to fall within one standard deviation of either side of the mean. And so the average, right, if the average is an 80, okay, and a standard deviation is 4, right, that means that around 70% of test takers fall within either 4 points above or 4 points below that score. All right, so we'll say in this case, we've got a standard deviation of 4 and a test average or mean of 80. If the average here is 80 and a standard deviation is 4, it means that between a 4 points below 76 and 4 points above 84, almost 70% of students fall in that range. But if the standard deviation, if we go to 2 standard deviations, that would be 4 points above is 1 standard deviation, 8 points above, so another 4 points, is 2 standard deviations. Now we have 96%. Okay, 96% of respondents fall within that. So that means that between 72 and 88 as the score on the test, we've got almost all of our students. There are some outliers, but the standard deviation tells us how tightly packed in our findings are. Okay, these are numbers that I probably would have a general idea of on a normal curve. 68% are within 1 standard deviation, and within 2 standard deviations, you've got almost 96%, so 95%. And ultimately, when you get to 4 standard deviations, you're at the 0.1%. So that looks like this. This is just a little bit more details on that. This is what like an IQ test or a Wechsler intelligence test scores would be. The standard deviation is 15, meaning that within 15 points above or below, you get 68% of respondents. 2 standard deviations, 30 points above or 30 points below, we've now got, you see here in the light blue, 96% of all respondents fall in that. And you can see this on the curve as well, right? This is the mode and the mean and the median. It's the measure of central tendency. Most of our respondents fall right here, right? This is how many respondents we have. Think of the y-axis as like how many responses you get. You don't have many out here on the outsides. Right, it's extremely small. 0.1% of respondents fall above a 145 or below a 55, but a huge number are going to fall here in the middle. Right, 70% within 1 standard deviation, 96%, 68 and 96. Sorry, 96% between 2 standard deviations. And that normal distribution curve is what we're often working with, but in psychology, we rarely get a perfect distribution curve, and so our variations can actually be much smaller or wider than that, right? Like a super tight variation, as you see here, we've got like and these would have an extremely small standard deviation because our scores are all pretty tightly grouped. We don't have a lot of outliers. Our range is from like 220 up through like right around not even quite to 400. Whereas here, our range is going to go from almost 100 up to 500, and our variation is going to be much, much wider. Okay, so a larger standard deviation, a larger variation. Way responses all over the place, whereas here it's going to be like much tighter. So average, the mean is good, it's very useful, but standard deviation along with mean is often going to be much more valuable. So for instance, Class A averages 82 on the test with a standard deviation of 15. Class B also averages 82, but with a standard deviation of 4. Which class does on the whole knows it better, right? Which class on the whole is going to know it better? Which class is going to have, or I'll say it this way, which class has more students that likely passed the test? The answer, of course, is the class B. They averaged an 82 with a standard deviation of 4, meaning that within 2 standard deviations, that's 8 points above or below, you've got 96% of people. That's all passing the test, right? 96% of people have an 82 scored 15 above or 15 below. That's a significant drop below as well, and you've got some outliers below that. That means that those students likely failed the test, if not did very, very poorly. So class B, as a whole, we had less students fail and were more successful. Second, you scored an 89% on the Unit 1 quiz. Would you want a high or low variation or high or low standard deviation for your other test scores for the remainder of the year? Of course, you would want a low variation because if you have a standard deviation of 12, it means you're going to have just as many scores at a 100 as you are in the 60s, right? You'd much rather have a low variation where if you have a low variation of like 3, it means that 96% of your scores fall within a range of 83 to 95, right? You want that low variation. Finally, we'll talk about inferential statistics. We've talked about descriptive. The other type of statistics, are these inferential statistics. This is often used when we're talking about like sampling, or it's still within often descriptive statistics, but it's asking that question within descriptive research, we use inferential statistics to figure out if we can generalize our information, generalize our data. Remember, the goal is to take our sample and then generalize, make conclusions about an entire population, because we didn't survey or study the entire population, we just studied a sample. So remember, random sampling helps us generalize. On contrast, remember, random assignment helps us be able to infer cause and effect when we are talking about experimental studies, okay? So inferential statistics, when we can infer causation, we need random assignment, but random sampling is figuring out if we can infer generalizability. Can we generalize it to the population? So we need that representative sample. Okay? We need to make sure that our sample is actually representative and not just chosen. That's why we do it randomly. And we need to control all the variables that we can, right? Make sure we can control all of those pieces. The more we control, the better, right? We may not control much, but we can control what we can in those surveys, so we can like remove biases. And then the larger the sample size, often the better, right? The larger the sample size helps us be able to figure out if our study is significant and if it can be generalized. And so the number we're looking for there is this little thing called a p-value, and that is ultimately known as statistical significance, meaning that it can be generalized. It means that it is significant, ultimately that it's not due to chance. Okay, so we can infer causation, cause and effect, with your basic surveys or with descriptive research. But if we have a good sample size, a representative population, a random sampling, and we do the math, you don't need to know how to figure this out. You just need to know what it means. And our p-value is less than 0.05. That means that the difference between these two things, or the connection between these things, it means ultimately that our findings are not due to chance. Right? It means that what we were looking for is not just random. It means that we did our study appropriately. We did a good job. And now we can generalize it to the larger population, right? And if it's above that in psychology, typically they're gonna say do it again, right? Especially, so you can see over here 0.001 up to 0.04, 0.03, very, very significant. 0.04 through 0.049 are all very significant. You can still claim that they are statistically significant, but 0.05 is that threshold where we start to say this might be random. We can say pretty confidently it's significant, but they're going to say, let's go do the study again to try to get that range between 0 and 0.049. So you want to get below less than a p-value less than 0.05. Anything else, it's not going to be it's really not going to be significant, and it means that the study wasn't done appropriately or didn't find any significance. They're not related. So p-value less than 0.05, looking for significance, statistical significance, meaning that it's not due to chance. Other numbers or variables you should know. P is that confidence interval of statistical significance. Okay. N is the N value you see is the how many participants you have or sample size. Okay, a significant the larger that number, typically the stronger your findings are going to be. Your confidence interval will be increased, or the p-value will be increased the larger your N value. Okay, so N equals the number of participants, and R, you often see, is a correlation coefficient. So what that looks like in correlational statistics, we talked about this a little bit before, but it is the strength of the relationship between two variables, be it positive or negative. You can see these here at the bottom. And R value of 1 is a perfect positive correlation, and R value of -1 is a perfect negative correlation. And that means that as one goes up, the other perfectly goes down the same amount. 0.8 or -0.8 are still both. You can see them in these dots. It's not a perfect line, but it's still a very strong correlation. 0.3, there's a correlation, but it's not super strong. R equals 0 means there's no correlation. Okay, there's another kind of example of that, what those look like. R0, perfect positive and negative correlation, and then some much weaker correlations. 0.5, you still see a line going through there, right? It's not perfect, but we still see the deviation between those. 0.7, right? We're still going to see some of that deviation between those, and -0.85, more variance, less variance on the -0.85 than we see on like the 0.5, with a decent amount of variance on those. Last thing to mention is meta-analysis, one of your final terms. This is essentially statistical analysis, but we're combining all of these different types of studies to make one finding, right? So whenever you have lots of different studies on the same thing, you are then able to do these meta-analysis, meaning that you're breaking all of them down, combining all of that data, meaning that you can have a larger sample size and you can have a higher degree of statistical significance or a stronger correlation coefficient. It basically will give you more reliable results. So meta-analysis, we're not going to go in depth as to how you do that for AP Psychology. All you got to know is if you see it, it means that they were taking into account lots of studies so that they could get a larger sample size across multiple studies. And pros is that it's also much cheaper, right? People have already done the work of the studies. You're just doing some analysis of previously done studies. You're not doing the surveys or the studies or anything yourself. You're just statistically analyzing previously done studies and then concluding based on all of their data instead of just one. Okay, we are going to close it there. It's a long, kind of confusing topic, but hopefully you got it by now. If not, I'll see you in class and we will talk about it then. And you are always welcome to reach out and let's chat about it. With that, we will call it a day. Much love, folks.